Hi everyone. I want to go over an example of what I think most people's projects are going to look like. And you're welcome to make your project as in-depth as you want to. And if you're pressed for time, you don't need to make it that complicated. And so this example is meant to be an illustration of how simple it can be for those of you who are pressed for time. Okay? So first of all, you want to choose a question that's very clear and well defined. And so I'm going to ask this question: does the stock market increase by an average of 5% per year? So you don't want to have a vague question that you're asking, like, you know, what would be an example of that? Does Salinas, California use a lot of water? It's not specific enough. You know, you want to have a nice, clear, numerical hypothesis that you can easily gather data around. Okay, so here we go. Does the stock market increase by an average of 5% per year? It's very, very specific, and the data that I'm going to go collect, I'm going to choose data that works for this hypothesis, okay? Works to test this hypothesis. So make it very specific, something like this. And then, once you've defined your question that you're going to ask in your project, go start tracking down some data. So I've opened up this search here in which I said, well, the Dow Jones measures market performance. So I'm going to get Dow Jones historical data, and I'd like it to be some sort of spreadsheet that has the data that I want. Okay? So this first link here, the St. Louis Fed is a one of the Federal Reserve banks, so it's a government resource. So that's what we want. We don't want to go to Yahoo Answers. We want some sort of official data source. Okay? And now you want to be very careful about what type of data you're looking at. So Dow Jones is the index that we're looking at, and it gives us different options for units. So let's just look at this. I haven't really seen it before, but let's just look at it and see what options we have. It has the index, which just says what was the price for that day. It has the change in the index. So what was the change in the index for that day? Change from a year ago. Ah, interesting. So let's refresh our memory on what we're looking at. It's literally giving us exactly what we want. Does the stock market increase by an average of 5% per year? So here, the very first link on that Google search gave us exactly what we want. Change in the index from a year ago. Okay? Frequency, daily, date range, wow, it goes all the way back to 1896. And then you can choose different options. So Excel would be a spreadsheet. I'm going to use comma separated. And then just download. So this is literally the first time I'm doing this. And so I'm working through it with you so you can see what your projects are potentially going to look like. Okay, so let's open up this data set and let's take a look at what it looks like. Very interesting. So looking at this data, I can see how this is working now. Okay, so looking at this data, remember what it was. It said change from a year ago. So let's take a look at this first set of values. Notice that there's nothing here. 1896 on May 25th. May 26th. There's no value showing. That's because it doesn't have data from a year prior. And this is basically the first data point for the Dow Jones Industrial Average. So there was no year before in order to measure the change. So if we skip ahead to 1897 at this date, 1897, oh, now we're starting to get some data. Okay, so this is the change in the index from a year prior. Okay. And so looking at this data, I see it's not going to be enough for what we want to do, because again, since this question was so specific and clear, it tells us exactly the type of data that we need. We don't want the change in the index, we want the percentage change in the index, right? So this data set measures the measures the numerical change in the index. We want the percentage change. So that's not going to work for us, and we just have to go back and okay, percentage change from a year prior. Now, it won't always be that easy that you can just find the exact type of data that you need, but in my case, I got lucky. Okay. Now that we've expressed this using percentage change, now we can see the type of data that we want. Percentage change from a year prior. Okay, so we've got negative 27%, so a big drop in the market. 12% change, so a nice gain from the prior year. Okay, and so these are the exact values that we want to measure our hypothesis. Okay, so this is the data set that we're going to use. Now that we have this data set, we're going to load this data set into R. Okay, and what you'll notice is that we have these values that we don't want. We don't care about these points here where there's no data. So what we can do is any of these where there's no data, we'll just delete them, right? Okay. So get rid of the times where there was no data, and now we just have nothing but percentage change from a year prior. Okay? Now that we're here, let's save this. I'm going to save it in the R folder that we've been using, and I'm going to call that percent change year I guess I'll just call it that, percent change over the previous year. Okay, so there we go. We've got a new name that tells us what that data set represents. So now we have that data set loaded into our R folder, and so let's use R and load it into the prompt itself. Okay, so just get rid of all that stuff. Let's introduce a new variable which we're going to call %.change.year. So percent change from a year ago. We're going to assign it this data set here, :r/percent change from a year ago, and the extension was .csv. The way those data elements were separated was with a comma. That's what CSV actually means, comma separated values. So they're separated with a comma, and there was no header. We deleted the top portion of this data set, so there's no header at the top, and it just immediately starts with data. And it gave us an error, which is fine, right? We just go through, figure out what the error was. It's probably in the name, percent change from a year ago. So let's go back into our folder. See what the folder was, or what the oh, it's a .txt extension. Okay, so we'll just change that from, instead of CSV, we're going to change it to .txt. Okay, so there we go. Little error there. I thought it was saved as a CSV file, but it turns out to be a TXT file. So now, when we type that in, it brings us all of those percentage change from the prior year. Okay? So what we'll do is we just want to select a nice sample, and so let's just choose a random sample. Okay? And what we can do is use R to generate a random list of data. So and you can use an online tool to do this if you want to. So just go to Google and type in random number generator. Okay, so here we go. Random number generator. Let's see. Okay. Let's choose a minimum of 1 and a maximum of, how many items do we have here? Looks like we have 31,811. So out of those 31,000 data points, let's choose this item in that list. Okay, so if you didn't want to use R, then you could just go to a random number generator, use that to generate items in your list. So we'll use the 2029. So we'll write this down. Okay. Generate another one, 16,363. 4066. And you can do, you know, however many of these you want. Something like 20 or 30 might be pretty good. So 13,382. 13,362. And so you just do 20 of these. Okay. 18,584. And so that's one way to do a random sample, is to just use a random number generator, and then in that list go in and find what item is in the 13,362nd position, and you'd use that percentage change from a year ago. Okay? Of course, R can generate random samples as well. So what we can do is, let's assign this variable x sample 1 through 31,000, replace equal to true. And we want, let's suppose that we want size 30, to where we'll have 30 random points. Okay? Then X has generated 30 random values that we can use, and we'll just pull out those items in this list. Okay? So now all you have to do is we'll choose this first item and we'll go to the 10891 position in this list. And it's not going to show here. Maybe it will. So what we'll, yeah, it didn't show. So what we'd have to do is we can take that %change.year and type in 10891. See what that gives us. We just want this column though. Let's take that third column and in that third column we're going to take the %.change.year, this data set here, and we want all rows, so we'll leave that blank, and we just want, that's the first column, second column, that's the third column, so we want the third column. Let me see, maybe that's the 0th column. You know, sometimes it just takes a little bit of fiddling with it to get it right. And now let's, sometimes these things start at 0, so maybe that's the 0th column, first column, second column. So you just try whatever you need to get it right. And let's see what data this third column now contains. We notice that, perfect, it took that third column of data and plugged it into a new object. Okay, so this third dot column now includes all the data that we wanted. So we know that we're going to take this sample of values. So all that we do is, to get this item in the list, we just type 10891 into third dot column, and that gives me that item on the list. So there it is, 83.83. Okay, and you'd write that into you know, maybe you could write that into a text file or something. So the first data point that we're going to use for this sample, 83.83. Okay. The next random data point we're going to choose is 17,182. And that gives us a change of 15%, you know, 15.84. Next random data point we're going to choose is 2851. So in that third column of data, we want the 2851st data point, which give us a change of 3% from the prior year, 3.166. The next random data point was going to be the 29,650th. So in that third column, we want the 29,650th item, which is 3.62, or we'll call it 3.63. And you can just keep going until you gather up all these items in your list. And then, of course, another thing that you can do is use R to gather them all at once. So, you know, sometimes you have to get a little bit creative if you want R to do all of this work for you. And so you may have to think kind of difficult, you know, think kind of hard about how you want R to do all that work for you. But I'm going to say it may be something like, you could certainly write a loop. And I'm going to say initialize I to be 1. Then I'm going to say while I is less than the length of x, meaning as long as you still have items in that random list of data, this while loop is going to run. And then I'm going to say the variable random is going to be assigned x I. It is going to be assigned third dot column of xi. Okay. This says choose the ith random data point and then plug that into third column and choose that random data point from the third column. I is then going to increment by 1. Increment by 1. And that should be enough. We may want to have less than or equal to here. Let me see. When I gets to the 30th position, we still want to have that line run. And then after I gets to the 31st position, the loop should break. Okay, so that's correct there. Okay, so just thinking out loud there. So if you want to get really fancy, then you can set up a loop. And this may not work. You know, sometimes they write stuff that doesn't work the first time. Let's go ahead and try it out. So I've hit Control R, and it ran, and it didn't give me an error. Okay, so let's type in random and see what it gave us. Didn't work. Oh, I see. I see what I did. There we go. That should work. Okay. Okay, so let's type in random now. And what did it do? It went through and it gathered that list of random data points for us. So the first one, just like we saw before, is going to be 83.83. So there's that. The next random data point said the percentage change from a year ago is going to be 1584. When we did it by hand, that's what we got. And we see that this loop has gone through and extracted that for us. The next year, the next item, when we did it by hand, gave us 3.166, and sure enough, that loop has extracted that data point for us. Therefore, we know that the loop has done its job and it selected the data for us. Okay? Only do this if you're really trying to get fancy. Now let's go ahead and just verify that we really did get 30 random points. And so let's do length of random. It gave us 30, therefore we know we have a sample size of 30. Okay? Now that we're here, let's just run the statistics. So let's calculate the mean of that random collection. Okay, so as I continued to try and work with this data set, I noticed that it was not behaving quite right, and that's because R was interpreting it as the wrong type of data. And so you have to run through a couple of little adjustments to this data set, and this is very typical of what you do in the real world as well, is sometimes things don't work out first couple of times. So you run through some adjustments to your data set, and you'd get the data set into the right form. So this is very typical of how you'd have to use R. Once we got this data set into the right form, now we can start running our tests. So mean 11.77. Let's do the standard deviation of our data. 25.24%. And so now that we have that, we're ready to run our hypothesis test. Okay? So our hypothesis test was, does the stock market increase by an average of 5% per year? So our H sub 0 is going to be, is the average equal to 5? And the alternate, H sub A, is the average different from 5. So not equal to 5. Okay? So there's our hypotheses. We would then calculate, in this case we're doing a hypothesis test of the average. So we would do t-test, right? And let's calculate our test statistic. We know the t-test statistic is x bar minus mu divided by s over square root of n. Okay, so this, write it out using the traditional math notation if it looks confusing. X bar minus mu over s over the square root of n. And so we would just plug this into R. We know that the null hypothesis was mu equal to 5. Alternate is that mu is not equal to 5. So our null hypothesis was that the average rate of return in the stock market was 5%. So we're going to take the mean for our sample minus the null hypothesis, divide that by sigma over the square root of n. Okay. And looks like I've made a little mistake here, so let me push stop, correct my mistake, which I've got parentheses there that are correct, and I need, let's see, I need one more set of parentheses here. Okay, so there we go. This is our t statistic, and there is the t-value. Okay, so we know that for a not equal to, we would have a two-tailed test. So we'd go back into R and we'd say, I'm going to find the area in the nearest tail. And since this t statistic is closer to the right tail, I'm going to find the area in the right tail. So I'll do PT, right, probability for a t-distribution. Our test statistic was 1.46. Our degrees of freedom is our sample size minus 1, which is 29, and lower dot tail equals false because I want to find the area in the right tail. So there is the area in the right tail. We know that for a two-tailed test, to get the p-value, you just double that area. So we'll double that, and we get 15. And so if we're testing this at a, say, 0.05 significance level, the p-value is 15, which is much greater than a significance level of 0.05. Therefore, we would fail to reject the null hypothesis. In other words, it's possible that the average rate of return in the stock market really is 5%. We cannot reject that as a possible average rate of return. Once you've run these statistics, you would then proceed to write up all the math that you did in a nice paragraph summary, and that little summary is just going to be your part of the independent, your write-up for the independent part of the project. Okay?